So students, Ms. Slyman here with the next part of advanced trig. We're going to look at the basic trig ratios. By that, we're talking about SOHCAHTOA, sine, cosine, tangent with right angles, and how that works if we're talking about angles in standard position and what cast is. So always if we're looking at an angle in standard position, we want to make a right angle with the x-axis. So it's super important that you use the x-axis. So if we have some angle in standard position, let's say it's here. So really the measure of our angle is here because we're measuring from the initial arm, which is the positive x-axis. But when we go to make a right-angled triangle, we're going to use the nearest x-axis. So here's my right-angled triangle. So looking at this, I would have, if I look at this point here would have an x value and a y value. If I want to find the length of the hypotenuse, I can use Pythagorean theorem. So that would be this r value. So r is my hypotenuse, and then I can use SOHCAHTOA. So if I'm going to think about SOHCAHTOA, sine is going to be, I'm looking now at the angle inside the triangle, the one that's made with the x-axis. So that's going to be my theta. And if I'm looking at sine, that's opposite over hypotenuse. Well, in this case, the opposite is the height, so that's the y value, so y over r. Cosine is going to be adjacent, that's the x value. So here to this point is my x value, that's my length of the adjacent over r, and tangent is opposite over adjacent. So even though we've got this theta here as our original theta, what we're saying is that even if we use this value, that sine of the blue theta is going to be the same as sine of the black theta. Yeah, so let me just write that below this here. That really sine of blue theta is the same as if we asked for the sine of the black theta value. And that's true for all of them as well. So notice that this angle is going to be an acute angle between 0 and 90. This angle here is going to be an angle that's going to be greater than 90, less than 180, but the sine values are going to be the same. They're both going to have this x over r value. They're both going to have this y over r value. The cosine for both of these would have the x over r value. So if I'm thinking about cosine of black theta and cosine of blue theta, they're both going to be negative because this x value is going to be negative. So negative x over r. I'll show you what I mean in some examples. So here we go, the point 512. So if I just think about a sketch, then I'll make my x-axis down here. We've got 5, and then we've got 12. So that point is about there. So if I put in a radius, well, this time theta is down here. So here I'm making my right angle with the x-axis. So if I think about this, then sine of theta is a ratio. Sine theta is opposite. So this value is 12. This value is 5 using Pythagorean theorem. My radius is square root 12 squared plus 5 squared. That's 144 plus 25 is 169. Square root of 169 is 13. So sine theta, 12 over 13. Sine theta, if you're asked for sine theta, you're asked for a ratio. The definition of sine is the ratio of the opposite side to the hypotenuse. So 12 over 13 is the ratio. Cosine of theta is going to be 5 over 13. Tangent of theta is going to be 12 over 5, opposite over adjacent. To answer the question, what is the angle? I can use any of these and find the inverse. I know that the value should be between 0 and 90. So I've gone ahead and shown that. I could use any of them. For every single one, I get the same angle, 67.4. So theta is approximately 67.4 degrees. And here I should have specified degrees. Okay, now for this next one, if I think about this drawing, I'm going to go to the left 3, up 4. That's going to put me about here. So if I think about my triangle, I've got -3 on the bottom, 4 on the top. That's a 3, 4, 5 triangle. And again, this angle theta, we're going to use this triangle with that green theta inside. And it's going to be the same thing. So sine theta is going to be 4/5. Cos theta is -3/5. Tan theta is 4/3, which I could write as -4/3, -4/3. Okay, so sine, cosine, and tangent are ratios. Now I've got a slight difference here. When I'm trying to find the angle theta, I'm trying to find this number. So I want a number bigger than 90, smaller than 180. Well, if I do sine inverse of 4/5, then what I get is 53.1. Well, 53.1, that's that green theta value. That's the distance from the x-axis. But notice it's not bigger than 180. Sorry, it's not bigger than 90. Really, if I want this black one, I have to do 180 minus 53.1. So I could have done that and gotten 126. So this 53 is the green theta. So then when I'm using the sine, black theta is 180 minus the green theta. If I had used my cosine ratio, if I had done cosine inverse of -3/5, well, my calculator knows that if cosine is negative, it has to be where x is negative. So it automatically gives me my 126.9, same as here. If I had done tan of 4/3, my calculator doesn't care where the negative is. So my calculator is giving me the angle -53.1. Notice it's 53.1 again. That negative though, the calculator thinks that the angle is down here, -53. So same distance, but your calculator doesn't know whether you're talking about the opposite or adjacent for tangent, which one is negative. So when your calculator sees the -4/3, it's thinking of this one. So my adjacent would be 3, the opposite is -4. So the calculator is giving this angle as the value. It's really important to draw a picture so that you know what angle you're talking about. Here we want this angle, bigger than 90, smaller than 180, because we always measure from our positive x-axis. So we have to give the theta value of 126.8 degrees. And I think that these two ways are the easiest to get there. Use sine, but then know that you have to subtract from 180, or we use the cosine. Okay, sine of 165, let's make a quick sketch. 165 is about here. Sine is going to be opposite over hypotenuse. That's going to be positive. So there, sine is positive. Cosine of 132.9. 132.9 is about here. Over here, cosine is adjacent over hypotenuse. Well, my adjacent value is negative. So cosine is negative in quadrant 2. Tangent of 342.9, 342.9 is around here. Tangent is opposite over adjacent, that's negative over positive, so tangent of quadrant 4 will be negative. And I'm using SOHCAHTOA to figure that out. My calculator agrees, positive, negative, negative. Remember that these values coming out are ratios. That's why they're all fractions, because they're all ratios. Okay, find the angles theta, given that theta is between 0 and 360. So now I'm told that I'm using degrees, so I can use degrees. So here we're saying that we've got a sine ratio of 0.76. So if I think about my sine is opposite over hypotenuse. My hypotenuse is always positive, so I want places where the y value is going to be positive. That can be here or here. And I made them tall because this is a pretty big ratio. So actually, maybe they need to be short now that I think about it. Nope, tall, because the opposite must be pretty big compared to the hypotenuse to end up with 0.76. If my opposite was short, then my decimal would be smaller. So I'm looking for values here and here because I don't know which one I'm talking about. But in both of those places, the opposite is positive. So if I go into my calculator and I do sine inverse of 0.7634, that's going to give me my first angle, 49.8 degrees. To find the second one, it's the same distance, so this second one is going to be 180 minus the 49.8. And I should have used approximate up here. And that would give me, oops, wrong way, 130.2. Okay. With this cosine being negative, I remember cosine is adjacent over hypotenuse, so I want the adjacent to be negative. That's going to be the x-axis. So that is negative over on this side. So my angles will be here or here. So bigger than 90 and then bigger than 180. This distance is the same as this distance here. So when I do cosine inverse, I get this one. I can then do 360 minus that to get this one. So I've got my two values. So cosine inverse gives me the 100, that's bigger than 90. 360 minus that gives me my 259.9. The other thing to do is to ignore the negative. So if I ignore the negative and just do cos inverse of 0.1752, I get 79.9. 79.9 is this distance here. So that would be that distance. But I know that I need the two values that are over here. So I need these values that have the negative x. I need this one and this one. Well, I could also know that this is 180 minus that 79. So that's this angle. Or 180 plus 79, that's going to be this angle of the 259. So either way, we're going to end up with our two theta values. So this top one, 100.1, this bottom one, 259.9. Okay, tangent being negative, tangent is opposite over adjacent, so one of those has to be negative. Well, I could have negative x, positive y, so that would be negative x, positive y, Or I could have positive x, negative y. So here's my two locations for tangent. If I just do tan inverse of that negative value, then I end up with a negative angle. So tan inverse of the negative value gives me the negative angle. So the calculator is thinking about measuring down, but I want to be positive angles only. So I know that measuring down is the same as doing 360 plus that down bit. So 360 plus negative 13 gives me the 346. Here I've got 180 minus that 0.13, so 180 plus that negative. 180 plus that negative. And again, we could have done what I suggested over here, just do the tan of the positive. That gives us the distance we're looking for, 13.1 degrees from the x-axis. So then we've got 360 minus 13.1, 180 minus 13.1. So here I've got my distance of 13.1. So 360 minus 13.1, 180 minus 13.1 gives me my two theta values. 346.9, 166.9. 166.9. Okay. So the sign, positive and negative, depend on where the arm is, obviously. So when we talk about sign, we're talking about positive, negative. And all you have to do is remember SOHCAHTOA. So if my arm is over here, opposite over hypotenuse is positive, adjacent over hypotenuse is positive, opposite over adjacent is positive. So over here in quadrant 1, all are positive. In quadrant 2, my opposite is what's positive, adjacent is negative. So in quadrant 2, sine is positive, and that's it. Because cosine is negative because of the negative x, tangent is negative because I've got positive y over negative x. So over here, only sine is positive. So all positive, sine positive. Down here, both x and y are negative. So tangent, being opposite over adjacent, negative divided by negative is positive. That means over here, tangent is positive. Quadrant 4, x is positive, so that means my adjacent is positive. So cosine is positive. So C, A, S, T is where that CAST abbreviation comes from. Cosine, all, sine, and tangent. I don't actually tend to remember CAST. What I remember instead is SOHCAHTOA and just draw my triangles. Okay, so again, a little bit more practice. So try to do this practice on your own. Notice that this one is degrees. I've got the answers posted for you. This one is in radians. So make sure to switch your calculator mode. And again, I've got the answers posted for you. But try it without looking at the answers. And I'll see you in class.